So today we'll discuss Unit 2 from June 2017, the MCQs. In the first question, which is the shortest covalent bond? So shortest covalent bond, you just have to check the shells, how many shells are involved in the structure. Using the number of the shells, you can identify the size of the bond. All the cases hydrogen is there, so hydrogen is one. But so like hydrogen and hydrogen, so they will have only first shell. But hydrogen, nitrogen, when you see, hydrogen is there, one shell, but nitrogen, for because nitrogen electronic configuration is 2 and 5. So nitrogen first shell, it will have 2 electrons, and the second shell will involve in the sharing. So the bond length will be longer. The correct answer is here because the hydrogen is the smallest atom. So when the two hydrogen atoms will form a bond with each other, they will have the shortest bond length. So that's why directly, even if we see the first part, you can clearly identify that hydrogen is having a shortest, because hydrogen is having only one shell, that's why it is having the shortest. Where hydrogen and sulfur, so sulfur is also the 2 and 6. So hydrogen is there, sulfur first shell, and then the second shell. So it won't be an hydrogen bromide. So bromine is having more shells, like 4 shells will be there, so it increases the size. Next one, which compound contain the bond which is greatest polarity? So basically the bond polarity depends on the difference in the electronegativity. The most electronegative element, as we move across the period, electronegativity, the tendency to attract the shared pair of electron increases. As we go down the group, because the size increases, so electronegativity or tendency to attract the shared pair of electron decreases. So which is the most electronegative element? When we check in terms of electronegativity, fluorine is most electronegative than the oxygen, and oxygen is more electronegative than nitrogen. So which is the most polar? This carbon and hydrogen, they have the similar electronegativity, so their bonds are like non-polar. So these three are polar bonds, but which one with the most or greatest polarity? The one which is having a greater electronegativity. So fluorine is the most electronegative element. That's why the hydrogen fluoride bond will have the greatest polarity. So when hydrogen will form a bond with fluorine, there will be a charge on hydrogen, partial positive, and there will be a charge on fluorine, but it will be greater charge as compared to hydrogen bonded with nitrogen or hydrogen bonded with oxygen. Then which compound has a polar bonds but non-polar molecule? So bond should be polar, but the overall molecule should be non-polar. So it means the molecule should be symmetrical molecule. When the molecule is having a symmetry, then overall it cancel out. So here carbon monoxide CO, oxygen is more electronegative, so partial negative, and carbon partial positive, so it won't be. Bonds are polar as well as molecule will also be polar. When we check hydrogen sulfide H2S, so sulfur belongs to group 6, so it will share 2 electron, and there will be a pair, lone pair, 2 lone pairs are there on sulfur. So because of the presence of the 2 lone pair, this will be a bent structure. So sulfur is more electronegative, partial negative, and hydrogen partial positive. But because it's a bent structure, that's why the two hydrogen, if it was a linear structure, then the two hydrogen dipole moment will cancel out each other. Like the tendency, if it was a linear structure, then both cases the sulfur has a tendency to attract electrons, so it will make a symmetry. But what happened, because it's a bent structure, so even in hydrogen sulfide, the two bonds will not be practically same length. They will have a different length as well. That's why it won't be symmetrical. If the molecule is not symmetrical, then it won't be non-polar. It will be polar now. Phosphorus, 5 phosphorus 3 chloride PCl3. So phosphorus is having belongs to group 5, so it will have two lone pairs, and 3 it used in a bonding, involved in the bonding. So again you can see lone pair. So whenever lone pair is there, what happen, it affect the geometry, the structure. So bonds are polar as well as molecule is also polar. But in carbon tetrafluoride, because all the bonds are identical, all the bonds are identical, so overall dipole moment will be zero. Like bonds are polar, one thing, because two different elements are there, difference in the electronegativity, which make the bonds polar. But overall, because all fluorine have the same tendency to attract electron and it is a symmetrical, that's why they all cancel out the effect of each other. As a result, the molecule will become non-polar. Another question: cyclohexane is a non-polar liquid. Therefore, so if it is a non-polar liquid, what is the tendency of a non-polar liquid? They are not affected by the electric field. So, and the idea is that the like dissolve like. Means if the molecules are polar, they will dissolve polar substance. That's why water tend to dissolve polar substances such as salts. So sodium chloride is very soluble in cyclohexane. That is wrong, because if it's a non-polar, it cannot dissolve the salt. That's why this statement is not correct. Cyclohexane conduct electricity. If it's a non-polar molecule, it does not have charges. That's why there is no. It's a simple molecular structure, so there is no free electron or ions. That's why it cannot conduct electricity. A jet of cyclohexane is deflected by a charged rod. That is also wrong. Why? Because it's a non-polar liquid, and non-polar liquid can not be deflected by the charged rod. Polar liquid can be deflected by the charged rod. And cyclohexane form two layers when mixed with water. That is true, because as I mentioned, like dissolve like. So if we mix non-polar, covalent compounds usually are like the organic compound usually are non-polar, except like alcohols, carboxylic acid. So non-polar and water is a polar. So when we mix them together, as a result, what will happen? It will produce two different layers. So D is the right answer. So the two different layers are actually formed due to the difference in the type or the nature of the molecules. In which reaction calcium oxidizes? What is the meaning of oxidation? Oxidation means like loss of electron or addition of oxygen. We call that as oxidation. So when you check an element state, the oxidation number is 0. Calcium chloride, so Cs plus, each chlorine is -1, so 2 chloride -2. But we check for individual. So calcium, what happened? It was 0, it become +1, +2. So if the 0 become +2, increase in oxidation number. Whenever increase in oxidation number, what we call this change? We call that as oxidation. So for calcium, it is oxidation, or A is the right answer. As oxidation refers to, the meaning of oxidation is a loss of electron or addition of oxygen or increase in the oxidation number. Consider the following ionic half equation. When these ionic half equations are combined, the full equation, the number of the electron loss should be equal to number of electron gain. So here the number of electrons are not same. So what we have to do? We have to multiply this equation by 2. So this will be 2, 2, and this will be 6. And the bottom equation will multiply by 3. So this will be 3 multiplied by 2, 6. This will be 6, and this will be 3. Now when we add the two equations, so the number of the electron will cancel out with each other. What we are left with? We are left with 2Al plus 6 proton, 6H plus, gives 2Al plus 3 or 3 plus 3H2. So we are left with 2Al, 6 protons, 2Al ions, and 3 hydrogen. So that's why D is the right answer. So whenever you want to write a combined equation from two half equations. What is the way to write the combined equation is we'll make the number of electrons same and we'll add the two equations. A metal salt gives a red color in a flame test. So what could be a metal salt? So if it is a barium is giving us green flame, and if it is a potassium it give a lilac, and sodium gives a yellow. So which one gives a red flame when we check the option? So this is giving us a green flame. This is giving lilac, yellow. So the red flame is due to lithium. So B is the right answer. What is the trend in thermal stability of carbonates, nitrates as a group 2 descent? Thermal stability, whenever we go down the group, what we'll observe, the thermal stability will increase. Even nitrate, carbonate or hydroxide. What is the reason for that? Because top of the group, like example, say we have magnesium, then we have calcium. If we have magnesium carbonate, magnesium ion is smaller in size as compared to calcium ion. So magnesium ion can cause more distortion to carbonate ion. As a result, when this magnesium causes more distortion to carbonate ion, it can decompose easily into carbon dioxide and oxygen, and that metal oxide will be there and carbon dioxide. But because calcium ion is larger in size, so it cannot cause distortion to the carbonate ion. Because of distortion, the strength of carbonate ion decreases. But because it can cause distortion, but not too much. As a result, this carbonate ion is more stable. So this calcium carbonate will decompose at high temperature as compared to magnesium carbonate. So whenever we go down the group, any type of compound, even it is a hydroxide, even it's a carbonate or a nitrate, thermal stability always increases as we go down the group. So D is the right answer. In question 9, which pair of a compound are more soluble hydroxide and more soluble sulfate? For this group 2, they mention here. So what is the trend? The solubility trend you have to learn. As we go down the group, they become more soluble. Solubility of hydroxide ion increases and solubility of sulfate decreases. So for group 2, the solubility for hydroxide, if it increases, like they become more soluble as we go down the group. But for sulfates, it become less soluble, does not dissolve. Like that's why barium meal or barium sulfate is used, as it is insoluble, does not dissolve. So which is bottom of the group will be more soluble. So which option? Hydroxide bottom. So either C can be an answer or D. And then for sulfate, because down the group decreases, so top of the group will be more soluble, and here bottom of the group will be more soluble. So top of the group, which is above, like when we check the position, because only two compounds are given, one is magnesium, another one is strontium. So if we have magnesium, when we are comparing the hydroxide, magnesium hydroxide with strontium hydroxide, so strontium hydroxide will be more soluble, dissolve. But when we compare their sulfate, like we have magnesium sulfate with strontium sulfate, so as we go down the group, the solubility decreases for sulfate, so magnesium sulfate will dissolve more. So magnesium sulfate and strontium hydroxide, that's why C is the right answer. So the trend you have to learn, that for hydroxide, as we go down the group, we find that the solubility increases. Whereas for sulfates, as we go down the group, the solubility decreases. The table shows measurement of uncertainty of each reading of some lab apparatus. The item of the lab apparatus that would measure the volume of 25 cm3 with the lowest percentage uncertainty. So how to work out the uncertainty? Basically, least count divided by value recorded into 100, that will give us the percentage uncertainty. So, so if you want to work out the low percentage uncertainty, that is uncertainty divided by value recorded multiplied by 100. If we are using the apparatus twice, like example, normally like balance, burettes, when we use, when we measure the volume, we measure the initial volume and final volume. So we read the burette twice. That's why the uncertainty will always be twice. So when we compare or work out, like for a burette, how to work out, we want to measure 25 cm cube of liquid. So for a burette, what will be the formula? The uncertainty of a burette, that is 0.05 times 2. Why times 2? Because whenever burette is used, we measure the initial volume and we measure the final volume. So we measure volume twice. That's why it will be divided, multiplied by 2 and divided by what? By value recorded 25 into 100. This will give the percentage uncertainty in burette. For a measuring cylinder, we just fill it, so we measure it once, but it is having a higher uncertainty as zero point 0.5 is there, divided by 25 into 100. And for a pipette, we just measure a fixed volume, so that is 0.06 divided by 25 into 100. And a volumetric flask, a 25 cm cube of volumetric flask, that is 0.1 divided by value recorded 25 into 100. So when we check which one give us the least, the smallest value, burette and volumetric flask are giving the same amount. So the pipette will give us the least or lowest percentage uncertainty. Is it clear, this question? That how to work out the uncertainty of apparatus, percentage uncertainty basically, using the uncertainties given. On adding chlorine water to aqueous sodium bromide, the resulting solution. So we are adding a chlorine water, so Cl2 is there. We added to sodium bromide, NaBr. As a result, what it will produce? It will produce sodium chloride plus bromine molecule, Br2 will be there. Then the equation must be balanced. So the balance equation here, 2 will put before sodium bromide and 2 will put before sodium chloride. So basically the resulting solution is due to the presence of a bromine. What is the appearance of a bromine? Bromine, you can mention, if aqueous bromine is there, you can mention orange, or bromine is red brown. It won't be pale yellow or green, that is the color of chlorine, yellowish green color. It won't be colorless because the bromine is there. It won't be purple. Purple, it can be in the, if iodine is there in the presence of starch, it will be blue black, not even purple. So that's why the red brown C is the right answer. Even if, for example, instead of red brown, if it was written orange, then you will select orange, because aqueous bromine is orange in color, pure bromine is red brown. In question 12, solid silver halide was tested as follows. Action of the sunlight, the solid turned gray. So it means the solid decomposed. Addition of a dilute aqueous ammonia, solid does not dissolve. So if solid does not dissolve, it means it might contain a bromide ion, because silver halide, so it might be silver, it might be silver bromide or it might be silver iodide, because both does not dissolve in dilute. When we add concentrated, the solid dissolve. So AgBr, both these are insoluble, and air also insoluble. But here AgBr only dissolve, AgI does not dissolve. It is insoluble in both dilute and concentrated. So option C is the right answer, that silver bromide is a halide which is present. That's why it dissolves in dilute ammonia, but it does not dissolve in concentrated aqueous ammonia. Question 13. This question is about the Maxwell-Boltzmann distribution graph. The diagram for an increase in temperature from T1 to T2. So we increases the temperature from T1 to T2. First, when we check option A is why it's wrong, because even at high temperature or low temperature, the peak, what will happen as we increase the temperature, the peak will shift towards the right hand side. Two things will happen. The peak will shift towards the right hand side, and second thing what happen, the height of the peak will decrease. So these are the two things will happen. So we have to check what happened according to the change. So why A is not right, because the height of the peak is same for both high temperature or low temperature. B, as you can see, T2 is a high temperature, temperature increase from T1 to T2. So T2 is a high temperature, T1 is a low temperature. So when we increase the temperature, the peak shifted towards the right hand side, that is true. And the height of the peak will decrease, that is also true. So that's why B is the right answer. Why not C? The peak is shifted toward the right hand side, but the height of the peak is increased here at high temperature. That's why it is wrong. And here the peak remain at the even high temperature. The peak decreases here, but it does not shift. That's why C is also wrong. In question 14, rate of a reaction between calcium carbonate and acid increases when? So there are factors which can affect the speed of reaction: temperature, concentration, particle size, catalyst, and for photochemical reaction, light also is one of the factor which can affect the rate of the reaction. So if the particle size and surface area are inversely proportional. So if the particle size of a calcium carbonate decrease, it means we are increasing a surface area. Like powdered form will have a large surface area, so it will react faster. That's why A is the right answer. Other option, 1 mole of nitric acid is used instead of hydrochloric acid. It won't make difference because both are strong acid. Then 0.2 moles of sulfuric acid is used instead of 1 mole. The same idea is because we are using the same amount, because 1 mole of sulfuric acid H2SO4 give 2 protons. So if we are using half mole of sulfuric acid, it will give 1 mole of proton. So that is the same thing. And if you are using 1 mole of hydrochloric acid HCl, it will dissociate into H plus and Cl minus. So if if 1 mole is there, it will also give the 1 mole. 1 mole of hydrochloric acid will give 1 mole of proton. So it's the same thing, like it does not make difference. The pressure increases here because there is no gaseous reactant. Pressure only affect the gaseous reactant. That's why pressure does not affect this equilibrium. So A is the right answer. Then in question 15, most significant factor determining the trend in the rate of hydrolysis of halogen butanes. So like we have halogen butane C4H11, C4 CnH2n plus 1. So C4H9 and Br, or halogen butane means any halogen can be attached, chlorine, bromine, or iodine. So on what factor this rate depends, the speed. Basically, as we know, if we have a carbon and chloride bond, carbon and bromide bond, and carbon and iodide bond. The bond, it depends on the speed of the reaction, depends on how much time it will take to break the bond. So because carbon and iodine is a longer bond, and bond length and bond strength are inversely proportional. If we have a longer bond, then the strength will be reduced. So the rate at which these halogen butanes react depends on the strength of a bond between carbon and the halogen. If the strong bond is there between carbon and halogen, it will react slower. If a weak bond is there, or a longer bond length is longer, then the reaction will be faster. As longer bond length means less energy is needed to break the bond, so can break down easily. So the electronegativity of halogen, it does not depend on electronegativity. As when we compare the rate, this carbon iodide bond will react much faster than carbon bromide, and that will react much faster than carbon chloride. So it does not depend on the electronegativity. The magnitude of halogen ionization energy, that does not affect, because ionization energy is not the factor here. The oxidizing ability of halogen, oxidizing ability means tendency to lose electron. So they have the tendency to not lose electron, they have the tendency to gain electron. Then it depends on the carbon and halogen bond strength. If we have a weaker bond strength, reaction will be faster. If we have a stronger bond strength, like strong bond is there between carbon and the halogen, then the reaction will be slower. So that's why carbon iodide bond or carbon and iodine bond is a weak bond, so it can be break easily. That's why the halogen butanes which contain iodine react much faster than bromine, and that react much faster than chlorine. In question 16, the action of ultraviolet radiation on an oxygen molecule at high temperature, uh, molecule high in the atmosphere, result in. So what is the effect? This is basically a formation of a ozone. This reaction leads to how ozone is formed, because what happened, the oxygen molecule, due to ultraviolet light UV radiation, it produces oxygen radicals or oxygen atoms, and these oxygen atoms, not radical because a pair of electron is there, so oxygen atom mix with another oxygen molecule to form ozone, O3. There's a dative bond. So what happened due to the, because ultraviolet radiation are used to produce free radical or used to break the bond. So no change, because O2 has no dipole. That is true, it does not have dipole, but there is a change. That's why this is wrong. Only increase the bond vibration, not does not only increase the bond vibration, actually it break the bond. The production of two oxygen atoms, that is true. The two oxygen atoms are produced. Formation of oxide ion, it does not produce an ion, because identical atoms are there. So, and in the same environment, it will be always a homolytic bond breaking. So it will result in a formation of a free radical. Then mass spectrum of propanol can be clearly distinguished from mass spectrum of propanol. Only propanol spectrum has a large peak due to, so how to identify the peaks for propanol, like to distinguish between propanol and propanol. So when we break the structure, say propanol is CH3, CH2, C double bonded with ONH, and propanol is CH3, C double bonded with O and CH3. When we break from left to right, we might have a peak at 15. We are breaking from left to right. Then we might have a peak at CH3, CH2. So 15 plus 14, that is 29. So we might get a peak at 29. And then we'll get a molecular ion peak. So when we add CH3, CH2, C double bonded with ONH. So when we add this all, till here it was 29 uh, plus 12, 41 plus 16, so 57 and then 58. So molecular mass is 58. Then we break from right to left. So breaking from right to left, C double bonded with ONH. So 12 plus 16, 28. This will be 29. Or we might have C double bonded with OH and CH2. So 29 plus 14, that is 43. And then we'll have a molecular ion peak, which is CH2, CH3. So that will be 58. But for propanol, if we break from left to right, because it's a symmetrical molecule, it does not make difference. So 15 will be there. CH3, C double bonded with O. And don't forget to write the charge on the fragment, because we always get a charge in a mass spectrum. Charge particle is there. CH3, C double bonded with O. So 15 plus this is 12, so 27 and plus 16, so 43. And then we'll get a molecular ion peak, that is 58. Then CH3, that is 15. Then CH3, C double bonded with O, 43. And then CH3, C double bonded with O, CH3. So this will be 58. So these are the fragments. We have to work out which one we can distinguish. 58. 58 is here. 58 is this one as well. So we cannot distinguish. A fragment of 57. CH3C CH3C5, like one H is removed practically, because this can also lose H, like on the left hand side there might be one H removed, so that is not the peak can be used, because if I remove H from here, this will be 57. If one H is removed from here, that can also be 57. Then when we check the third one, 29, so 29 is here, but you don't find 29 in propanol. So it means it can only be there in propanol, but it cannot be there in propanol. And 15 is already there. You can see this 15 is there in propanol and 15 is there in propanol. So we cannot use these peaks. We can only have fragment at 29 to distinguish whether it is propanol or propanol. In question 18, a sample of butanol is oxidized by heating under reflux with an oxidizing agent. Then a product was separated by infrared analysis. Apart from the peak due to CC and CH, which peak would be present in IR spectrum? So first we have butane to all. Butane to all means but means 4 carbon are there, and OH with a second. So it means it is a secondary alcohol. If it's a secondary alcohol, it will be oxidized to ketone. So it will produce butanol. So butanol will be the product, or butanol will be produced here. So how we can identify it's a butanol? Distinguish, because butanol will have only C double bonded with O. There is no other peak, so only C double bonded with O will be there. That's why A is the right answer. Other peaks of, they already mentioned CC and CH bonds are there, but other than this, what could be the peak in IR spectrum for oxidation product? So because it is producing a ketone, and ketone will be C double bonded with O, that's why this peak will only exist. If it was a primary alcohol, then C double bonded with O, OH and CO, so D will be the answer. But it is a secondary alcohol, so it will result in a formation of ketone. Which greenhouse gas is produced only as a result of anthropogenic activities, means human activities? Which is the greenhouse gas which is produced here? So carbon dioxide result in both, like example, due to human activity as well as due to the environmental changes. So it, because they mention only by dichloro difluoromethane. So basically, this is used as a refrigerant, and this is a man-made compound. So that's why this will contribute to greenhouse. Methane naturally produce. There are processes which produce water vapors also naturally produce. So due to the human activity, this is a compound like we produce naturally. It is not there. This compound we are producing this as a refrigerant gas or fire retardant. That's why B is the right answer. The first ionization energy of strontium is less endothermic than of calcium. Like if we want to remove the first electron from strontium, we don't have to supply too much energy as compared to that of calcium. As we go down the group, calcium and strontium is below. Strontium is larger in size, calcium is smaller in size. Both belongs to group 2. So if we want to remove electron from strontium, we need less energy as compared to the energy needed to remove electron from calcium. What is the reason for that? The best explanation, more protons. So strontium is having more proton. So if it is having more proton, then strong attraction should be there. But attraction is weaker, so that is not the answer. More proton and neutron, that's not the answer. It has 18, not 8 electron in outer shell. That is totally wrong. There are more inner shells because strontium will have more electron shells or more inner shells, so greater shielding effect. As a graded shielding effect, what will be the effect of the shielding effect? The force experienced by this electron in the outermost shell, that will be weaker. So by a small amount of energy, we can remove these electrons out from the atom. So it will be much more easy to remove these electrons from the strontium atom. So this was unit 2 from June 2017.